let's start. क्या है अपना टॉपिक आज का?
Equilibria and reaction kinetics.
तो देखो इक्विलिब्रिया में एक्चुअली फर्दर एस्पेक्ट्स ऑफ इक्विलिब्रिया नाम का टॉपिक है अपना, है ना. व्हाट डू वी ऑलरेडी नो अबाउट इक्विलिब्रियम? वी नो कि एक इक्वेशन बनती है, अगर रिवर्सिबल रिएक्शन है तो कोई तो के वाली रिएक्शन बनती है जिसमें प्रोडक्ट्स अपॉन रिएक्टेंट्स लगता है ना. जो भी प्रोडक्ट है उसका अगर कंसंट्रेशन हो तो रेज टू द पावर ऑफ इट्स स्टोइकियोमेट्रिक वैल्यू फॉर बोथ ऑफ देम. अगर एक से ज्यादा रिएक्टेंट्स है तो R1 R2 R3 R4 raised to power A B C D whatever, है ना. all of them will be multiplied, right? This year we understand that how to further use equilibrium, right? Further usage of equilibrium, let's see in the textbook how do they start. So further aspects of equilibrium, we go to page 438. Okay, and he also wanted to cover Gibbs free energy if possible today. ऐसा मैंने बोला.
So all three aspects of equilibria, reaction kinetics.
Oh right, sorry, reaction kinetics, not this. Right. So just remembering what is equilibrium again. So they have explained with a similar kind of equation. ऐसे कुछ explain किया textbook में. But they have also explained ionic product of water, right? So Kw. See, water dissociates like this, H plus and OH minus. This is actually H3O plus. But for easy understanding, you can take it as H plus, है ना. So Kw, because जितना भी water ionize होगा, so Kw will be equal to H plus concentration into OH minus concentration. And for water, the value of Kw is equal to 1.0 10 to the power minus 14 mole per dm cube whole square, right? Because concentration is multiplied twice, right? And then they start with pH calculation. The pH calculation is equal to minus of log H plus concentration and log is to the base 10, right? From here you can find out the concentration of H plus ions if pH is given by changing the equation. You can write E raised to pH is equal to minus, E raised to minus pH is equal to H plus concentration. But considering that water was dissociating like this, that H plus dissociates to H plus and OH minus, and if this is 1 mole, these also have to be 1 mole each, making us understand that in Kw, which is H plus concentration into.
Sir, अगर आपने pH आपको तो 10 raised to power minus pH था, not E raised to power.
Sorry, 10 raised to, right? So if Kw is given, H plus and OH minus can be found out. But how? If it is water and there is no acid or base, right? We consider that the concentration of both of these things are equal, and therefore 1 into 10 to the power minus 14 is equal to x square, where x comes out to be 1 into 10 to the power minus 7. When you find pH of this, right, when the number of H plus and OH minus ions are equal, you will find that the pH is equal to 7, which is the neutral pH, right? So if, because pH formula goes like this, so if the H plus ion concentration decreases, the value of pH increases, right? The H plus ion concentration increases, the value of pH decreases, right? This is how we can find out. So even if you know the concentration of OH minus, you can keep it here. Let's say I want to find out the pH of potassium hydroxide, which has a concentration of, let's say, any number, right? Which means KOH is a very strong base, right? It will completely dissociate to K plus and OH minus ion. So whatever is the concentration of this is also the concentration of OH minus ions. What will happen over here? That if OH minus ions increase, the H plus ions comparatively are now less, right? So what would happen here, if I increase the OH minus ion, because there is an equilibrium, the equilibrium will shift to left. Because it shifts to left, H plus ion concentration will also decrease, right? And hence what you can do, you can use Kw, find out H plus and then find out pH. But there is one more method, right? What you can do, you can find out log to the base 10 OH minus concentration and subtract it from 14. Let's say this is X, so 14 minus X will also give you the pH, right? So you can go longer way and find out pOH. 14 minus pOH is pH, right? So that is there. Then, so that is the first thing. So that is how you find out pH from these values. Now what happens is, if you take out your calcium and find out log to the base 10 of 10 to the power minus 10, what do you find out?
Minus 10. Minus 10.
And if that is multiplied with the negative sign, becomes plus 10, right? What does this mean? That 10 to the power minus 10 is the power of concentration of H plus ions. Yeah? So they have decreased, right? But if there is very small change in that concentration, when is there is small change in this concentration? When it is either a weak acid or a weak base, right? So when there is only small concentration change, what will happen? The value of pH itself is very, very small, right? Look at page 446, right? Let's look at the value of just a second. Okay, look at benzoic acid, right? Let's find out. So it is 6.3 into 10 to the power minus 5. What is this? This is Ka of benzoic acid. And if you don't know what is Ka is nothing but, let's say benzoic acid is C6H5 COOH. Right? Should it be that? Yeah. If this dissociates, it should form C6H5 COO minus and H plus. Right? Here what will happen? Ka is equal to H plus into A minus. This is the anion upon H. Right? The value of this thing is 10 to the power minus 5. So the value of H plus ion is even going to be smaller. The value 10 to the power minus 5 means that this is more in the concentration compared to the products themselves. Right? Because this happens, the value of H plus is very small. And if you then find out pH, it becomes much less. Right? It cannot be even calculated properly. So what do? You find out Ka first and then you find out pKa. For weak acids and weak base, for bases it will be P into Kb. Right? Concentration constant or coefficient of bases. Right? So that is that. Again, pH can be found out just like, see, pKa is somewhere equivalent to pH. Here, if you had taken the concentration of H plus, it would be pH. So this is something comparable to pH, right? Now, if you look at the same table, you will find out table 21.2, right? The first acid, nitric acid, right? Nitric acid has a Ka of value 40. What does this mean? That the acid is very strong. The H plus ion concentration is 40 times, if not square root of 40 times, right? It is square, like if these two concentration are equal, and they will be equal if you look at the equation, right? Anion and cation, or H plus and anion concentration are equal. In that case, you will find that the value of H plus concentration is a square root of 40, which is much higher. And when for a positive value, right, because there is already negative number here, when you find pKa of a positive value, you find that the number becomes negative. It tells you that the acid is a strong acid, or if you have taken base by mistake, it's a strong base, right? It will immediately give a negative value which indicates it is strong. Make sense, guys?
Yes.
Okay. Now, if you look at this worked out example, that calculate the value of Ka for methanoic acid solution which has a pH of 2.9. Now, if you have pH, right, these calculations are important when you look at buffer solutions. Right now, this is a smaller part of calculation, but it will become important when it is a buffer solution. So, if pKa has to be, or rather just Ka has to be found out, right, you can start with pH. pH is nothing but is equal to minus of log to the base 10 H plus concentration. Once you have this H plus concentration, right, you can use the value Ka. And what is this methanoic acid? So HCOOH is it? Yes.
Yeah.
So HCOOH, right? This is methanoic acid. What will happen? The Ka, this reversibly will give you COO minus, HCOO minus and H plus. So H plus into HCOO minus upon the concentration of HCOOH. This is already given in the question. This can be calculated from this equation, and therefore if this is X, this also will be X, because when this dissociates, they dissociate in equal ratio, and therefore you can find out the value of Ka. Right? Calculating the value of pH of a weak acid. Now once, yes sir.
मैंने pH H प्लस की कॉन्सेंट्रेशन निकाली -1.26, ठीक है। उसके बाद अपने को सोल्यूशन ऑफ 0.01 मोल पर डीएम क्यूब दिया हुआ है, तो वो कंसेंट्रेशन भी अपने को पता है मेथनोइक एसिड की वो तो HCO माइनस की कंसेंट्रेशन क्या होगी? सेम रहेगी 1 मोल से, क्योंकि 1 मोल से तो दोनों सेम है।
तो जितनी इसकी निकाली उसकी उतनी ही होगी। Now, while he is doing this, can you also understand that if Ka value and concentration value are given, you can find out the value of pH, right? Let's suppose in this equation only, if you were given Ka and pH, you can find out the, if they are given this denominator and the value of Ka, you can still find out H plus, and hence you can find out the value of pH. It's just reverse calculation. Makes sense? Now, if you understood this, let's look at buffer solution. What are buffer solutions? Buffer solutions are the solutions which changes pH or addition of acid or base. Little bit,
small amounts.
Small amount, very important. Because on unlimited dilution, it will for
It will
sure
100%
change its pH. Right? What is buffer solution made of? Buffer solution is made of weak acid and its salt. Okay, weak acid and the salt of weak acid. We will change the quantity of salt and weak acid to get a required concentration or pH of buffer solution.
Yeah.
You can also use weak base and the salt if the pH required is greater. But practically pH क्यों हमको, अगर तुम लोग देखोगे जितने भी तुम्हारे क्वेश्चंस हैं, pH 0 से 7 के बीच में कुछ 5.4, 6.3 ऐसा रिक्वायरमेंट होता है. Why? Because when we look at chromatography, when we are trying to do electrophoresis, तो उसमें जो buffer solution यूज होता है वो थोड़ा सा acidic होता है. When you add amino acids to it, the pH might change. तो pH का buffer solution का purpose क्या है? कि सबसे पहले तो यही pH पकड़ लो, that on addition of little bit of amino acid, the pH should not change, right? So for that achieve, like उसके लिए ये buffer solution पहले समझना पड़ेगा. Even before how does buffer solution works, let's also look at common ion effect, right? अब common ion effect हमने already indirectly समझ लिया, right? H2O was dissociating to H plus and OH minus ion, and if I add KOH to this solution, because KOH is a strong base, what will happen? It will dissociate to K plus and OH minus. Now, in the same solution, the concentration of OH minus ions increase, right? KOH does not want to go back to its lattice form. It wants to stay as free ions. It wants to stay dissolved, है ना? Rather hydrated के बाद dissolved होता है. तो एकदम lowest, it has given all the heat, right? All the energy rather, and it is in this form. So it wants to stay here. What will happen? Here the concentration of OH minus increases. So the reaction will go to the left hand side, right? And therefore the equilibrium between H plus and OH minus ion भी तो exist करता है. 10 to the power minus 7 mole per dm cube है दोनों. क्या हो जाएगा? H plus ion कम हो जाएगा. OH minus ion तो already हमने ऐड किया, तो it will stay, but the amount of H plus ions will decrease, right? This is, see, मैंने तो base और water लिया, but common ion effect क्या है? That if there is an ion which is a result of a reaction that goes to completion, it will disturb the equilibrium of another reaction which has
It's so this was all done in one solution. There was one solution of H2 where H2 dissociates and we added KOH on top. Okay.
right. This is what happens.
उसके कारण when we added KOH, उसके कारण ऊपर जो H plus की concentration थी वो अपने आप decrease हो गई, तो solution became more basic.
Right. Now what will, yes.
Sir, what happens if both of the reactions are reversible reactions?
If both of the reactions are reversible reactions, then we will look at case step. The one that is more stable will go more towards the right, which is also part of our discussion. But that becomes a part of transition elements. Right? Case step you generally see how much they are soluble. Right? So if let's say we are talking about barium sulfate, then there is an equilibrium because barium sulfate is not completely soluble. Right? So you will look at that as well. In that case, you will not have this reaction. But what is happening here? If a reaction goes to completion and there is a common ion with in the same solution with another reaction that has a reversible possibility, right? And you are adding product, what will happen? Due to the common ion, the equilibrium will shift. This is what we take advantage of when we are making buffer solution. What do? We add, let's say there is an acid and there is a salt. Okay. What will happen? If you add an acid, right? Let's take one example over here, right? This will give H plus and COO, HCOO minus, and let's say this is COO, a weak acid, and the salt of that acid only. This goes to completion to form Na plus and HCOO minus. Now, if you look at it, this is the common ion, right? If a base is added to this solution, what will happen? H plus concentration will
You're adding more. It will reduce. This HCO will increase and H plus
concentration will reduce होगी ना.
उससे क्या होगा? अगर H plus concentration ही change हो जाए, if
pH
H plus is used up,
बढ़ेगा
तो pH बढ़ेगा.
बढ़ेगा
acidic होता है, हाँ बढ़ेगा.
But यहाँ पे क्या होगा? Because this is an equilibrium, the equilibrium will shift towards right, and it will take care of all the OH minus that you added. क्या होगा? तू जैसे
ये reaction
base add करेगा क्या होगा?
बेस ऐड किया तो इक्विलिब्रियम जो है वो लेफ्ट साइड पे शिफ्ट हो जाएगा, क्योंकि अगर HCO माइनस
यूज होगे, what is an acid and what is a base that accepts proton?
हाँ,
तो it will accept this proton.
which base?
H plus.
नहीं वैसा नहीं है, अगर नीचे वाला जो रिएक्शन है वो बेसिक है तो वो
कंप्लीशन पे चला गया,
कंप्लीशन में चला गया,
उसका कुछ नहीं कर सकता.
उसके कारण ऊपर का जो है वो इक्विलिब्रियम इफेक्ट होगा. ऊपर का इफेक्ट होगा मतलब तुमने जब
अब एस्टैब्लिश हो गया, तूने एसिड डाला, लेट्स से pH 5.8 आया, है ना? अब तूने थोड़ा सा ये डाल दिया तो रिएक्शन वापस चला जाएगा.
हाँ.
तो समझ ले कि 5.8 की जगह पे 6.3 हो गया, क्योंकि वो थोड़ा और न्यूट्रल के साइड चला गया. अब तूने बेस डाला,
एक और बार
थोड़ा सा, अब तूने फाइनली थोड़ा सा बेस डाला, तो क्या होगा?
बेस डाला तो वापस से रिएक्शन राइट साइड पे शिफ्ट हो जाएगा.
Right? So what will happen? The reaction actually happens in such a manner that OH minus ion reacts with this H plus, decreases the concentration of H plus, and the whole reaction moves to right? What will happen? The pH will try to remain same for
Yeah.
certain value. जितना OH, अगर मैं unlimited OH ऐड करूँगा तो H plus सारे react हो जाएंगे, equilibrium break हो जाएगा. But if there is little bit of OH, then the equilibrium re-establishes. है ना? Last year we have already understood that no matter what concentration you change, the position of equilibrium remains same. है ना? Position of equilibrium was changing only with temperature. The equilibrium was bending in whatever way you like, but the position of that fulcrum of equilibrium changes only with temperature. बाकी जगह पे तो equilibrium का वही रहेगा, है ना? Now what will happen? So the equilibrium is re-established and the pH remains constant, right? अब अगर तुमने base ऐड कर दिया तो क्या होगा? Sorry, acid ऐड कर दिया तो क्या होगा? Left side पे जाएगा. In this manner, because of this common ion, what will happen? The pH will be maintained. है ना? So I believe कि यहाँ पे प्रॉब्लम नहीं हो रही, प्रॉब्लम हो रही है बफर सॉल्यूशन दिया है, फाइंड आउट द pH ऑफ बफर सॉल्यूशन, और pH दिया है एंड फाइंड आउट द कंसंट्रेशन ऑफ H प्लस और OH माइनस आए, उधर अपने पसीने निकल जाते हैं कि अब क्या करेंगे, है ना? तो लेट अस टेक अ सर्टेन क्वेश्चन दैट डज दिस, है ना? पूरा टेक्स्ट बुक में एक्सप्लेन किया है, एज फार एज आई अंडरस्टैंड कि पूरा टेक्स्ट बुक में बहुत सारा एक्सप्लेन किया, पेज 449. We can use this equation to explain how buffer solution work. Increasing in hydrogen, they have taken another acid and probably a salt of that acid, right? So they have given another example, but it achieves the same thing, right? Now they have given a direct equation that what is the calculating pH of a buffer solution. So they have written this equation that H plus is equal to concentration of H plus is equal to
So क्या page number
Ka. The very next page 450.
Yeah.
Ka multiplied by the concentration of the acid upon the concentration of the salt, right? And therefore, if you take pH over here, right? What is pH? pH is taking log on both sides, correct? If I take log on both sides, what will happen? This becomes pH. This will Ka becomes pKa. And what happens to a multiplication? Plus log of acid concentration upon the salt concentration. Make sense?
Yeah.
है ना? So salt is also used up somewhere. Let's find out in the last page. Just a second. H plus ion shifts the position to the left because combined with for more until equilibrium is re-established. That is the supply ensures that the concentration. Okay. So they are saying that the job of this equilibrium is to give a large concentration of HCl because this reaction goes to completion. So to give a reserve amount of this anions so that the reaction can successfully go back, right? See, we understood that what is the role of the first reaction, equilibrium, so that the equilibrium can shift left and right. Okay. But what is the role of this anion? The role of this anion, because this reaction goes to completion, there is a large supply of this anion, right? This H plus ion will dictate the pH of the solution, so that must not change. But for this to not change, if there is an acid added, the reaction should not go to the left hand side. First, some of this will react, right? Enough?
Yeah.
Some of this will react and go to the left hand side. But what will happen? This second reaction gives a very large supply of this anion. So even if you add an acid, the reaction can stay on that side. It does not go back. Right? Now let's look at an example. Calculate pH of a buffer solution containing so much propanoic acid and so much sodium propanoate. You can directly use this. And they have given the concentration of acid and salt. You can directly use this. They have given the Ka of propanoic acid as well. But these are not the type of questions they ask in boards. है ना? अगर तुम्हारे पास क्वेश्चन नहीं है ऐसा तो I will not solve it. तो हम आधे क्वेश्चन सॉल्व करेंगे, है ना. Uses of buffer solution, they have explained uses of buffer solution. Then we have KSP. What Shaurya was asking, that sir, what will happen if the reaction does not go to completion? So we first find solubility product. How much of this does dissolve? KSP is, let's say, barium sulfate, right? This will form Ba2 plus and SO4 2 minus. This is not completely soluble, है ना? As we go down the group 2, the solubility of sulfate and the hydroxide. So I could have taken hydroxide and again we could have understood this in that way. But barium sulfate, what I will do, I will write Ba2 plus concentration into SO4 2 minus concentration. Right? If I was looking for MgCl2's KSP, right? Although this is very soluble, but let's say for our sake, right? All chlorides except lead chlorides are soluble, है ना? 10 का थोड़ा lead and silver chlorides are soluble. So in that case, this will have a power of 2, है ना? And in your exams they do this. What will they do? They will say that okay, because magnesium sulfate is very soluble, let's take PbCl2, right? This resolves like this, Pb2 plus and Cl2Cl, right? They will tell you that KSP of PbCl2 is known. Find out the concentration of Pb2 plus. What will you do? You will take the concentration of this thing is x and therefore the concentration of this thing is 2x. But KSP is equal to x into 2x raised to power 2. This will become 4x cube. You make a mistake here and here. Even if you know what KSP stands for, you will not get your marks. So remember to look for stoichiometric ratios in KSP. It is just about solubility. Okay. Now the next topic will be how can you predict precipitation. Now we already know common ion effect and we know there is something known as KSP, right? Let's say this is less soluble as we know, right? If I add sodium chloride to this, what will happen? It will again form the solid,
Cl minus ions will increase.
right? Cl minus ions will increase. What is this? Common ion effect.
Yeah, oh.
Right?
Yeah.
And therefore this will happen. Okay? So if it is very less soluble and you add a common ion, you will look at precipitation. You will find precipitation happens. Does this make sense?
Yeah.
The greater the value of KSP, the more soluble it is. So things that are completely soluble will have very high value of KSP. If there is such a solution given, let's look at that. Okay. No, they have not. They have not. Right? See, for barium carbonate, the value is 5.5 to 10 to the power minus 10, which means barium carbonate is very, very less soluble. Right? Calculating solubility product from solubility. Right? What they have given on page 54, they have given a question, work the example. Calculating solubility product from solubility. A saturated solution of magnesium fluoride has a solubility of so much. Calculate the solubility product of magnesium fluoride. So what I will do? I will write MgF2, right? Let's say reversibly gives Mg2 plus and 2F minus. Can you help me the value of this concentration? What is it?
It is 1.22 times 10 power minus
10 power. So this will be 1.2 into 10 to the power minus 3, but this will be 2.4 into 10 to the power minus 3, and your answer is 1.2 into 10 to the power minus 3 multiplied by 2.4 into 10 to the power minus 3 raised to power 2. And this is how you find out the KSP. And then what you will do to the units, you will write mole per dm cube raised to power 3, because 1 plus 2 is 3. Easy, you can find this out. And calculating solubility from solubility product, just reverse the step.
Yeah.
If a KSP is given, find out the value of x. write down this equation and then substitute that how does it
Form.
है ना उसके लिए एक सीधा सीधा क्वेश्चन दिया है. So I hope that you can do this. Then there is partition coefficient. What is the partitioning
Is
coefficient?
the ratio of concentrations of two invisible solvents.
Right? So what will happen? Let's say I want to dissolve ammonia in benzene and water. Ammonia has different solubility in benzene, different solubility in water. What I will do? I will first take ammonia, dissolve it in polar solvent, which is water. For our example, it is water.
Water.
Then I will take this ammonia, I will take the solution of water and ammonia, and then I will shake it with benzene.
Yeah.
Right? What will happen to benzene? It will absorb or it will dissolve some of the ammonia in it. Right? Then I will let it stand in a separating funnel. Inside this separating funnel, what will I do? I will take out some water, because here water is denser. If your non-polar solvent, benzene, right? If that was heavier, you would take that.
That.
But water is important over here, because now I am going to perform titration and find out the concentration of ammonia in water. So what can I do? I can take a strong acid and I can perform titration, because ammonium hydroxide is formed with water.
Yeah.
Because ammonium hydroxide is formed, I can actually find out the concentration of ammonia in water. Once I have concentration of ammonia in water, right? How did I start this? I said that okay, let's take 100 ml of water, or let's write 100 centimeter cube of water, in which add 10 gram of ammonia. So you have the original concentration. Then what you will do? You will add 100 centimeter cube of, so this is aqueous solution and this is non-polar solution, or polar and non-polar, let's write. Right? You will take 100 centimeter cube of this. Right? First this is dissolved, then this is added, then it is shaken. All of this is added to a separating funnel. Ideally water is the heaviest, so it sinks down. You take out some water. Right? Water was 100 ml. I took out only 10 centimeter cube of water. Or let's say 25 centimeter cube of water. Then what will I do? I will perform a
Titration.
right? They will ask that what is the amount of moles of ammonia that dissolved in the non-polar solvent.
Yeah.
For that, what you will do? First, find out the number of moles in 25 centimeter cube. Then you multiply it with 4.
Correct.
है ना?
That's the four.
And then subtract this moles from 10 gram.
Yeah.
So 17 gram is 1 mole. 10 gram will be something. So subtract it from over there. है ना?
Yeah.
So although this method looks very straightforward, you will lose mark in step number 1. You will forget that you have to find the moles of this thing.
Of 10 grams. Also.
Right?
Yeah.
Then you will forget that this was actually just 1/4 of the solution. Third is, you may forget to actually find out the moles. You will just leave it at the concentration of this 25 centimeter cube wala solution.
Yeah.
Because you will have the equation, you will think that okay, concentration mil gaya, mera answer aa gaya. But that is not the answer. From concentration you have to work to moles. From moles you have to work to mass. And first
Subtract
that
the
moles
mass.
must be divided, multiplied with whatever part you have taken. If it was 1/8, multiply by 8. If it was half, multiply by 2, whatever. And then subtract it from the original quantity. That much has dissolved in the polar solvent. है ना? So what is this ratio called? The ratio is known as partitioning coefficient. Right? Sometimes they will ask you directly Kpc, find out the value of Kpc. So one more step will be added. You know the concentration right now in aqueous. You will have to find concentration in non-polar, right? And use this equation that Kpc is equal to X, concentration of X in solvent A and concentration of X in solvent B. And think instead of solvent A and B, you can write aqueous. Okay. So Kpc is X in what did they write? They gave it organic solvent. है ना? And X upon X of aqueous, है ना? इन दोनों का concentration, that is Make sense, guys?
Yeah.
And just give me a minute and take out your questions, please. Let's discuss some questions.
That's you. Spider. Nice one. Come on.
Questions है?
परफ्यूम डाल दे
घड़ा से हमारा लोगों ने ये से दिया वाला है
नाइस एकदम
हाँ मॉडल
नाम है तो ना पूछो हम भाई कैसा
पति हो?
चैप्टर हाँ चैप्टर पर दिया
और शायद बीजू चैप्टर भी है
रिएक्शन काइनेटिक्स
हाँ પછી मैथ्स
सारा डायट पर तू जो सारे फैंसी कुकिंग करता
How do you use KPC in paper?
You don't.
वो देखा है
you
you do
I mean but you can you have if you have a wish then you don't exactly I would not personally because I never do chromatic method तो कभी chromatography करेगा लाइफ में
ओए लेट्स सी
वो
देखना धान क्या छोड़ रहा है उससे
नहीं करेगा
कभी ना कभी तो गिरेगा
कैसे हुआ
ओए लेट्स सी कितनी देर तक है
हाँ,
छोड़ क्या था
सक्शन
मैं कुछ नहीं होगा
सक्शन
क्या
लगाना चाहिए
व्हाट
एक काम
सक्शन
करते हैं रुक
ओह शिट
निकाल
इससे अब गिरेगा
नहीं ऐसे सीधे थोड़ा गिरेगा ऐसे भी गिर सकता है
एक को है
ओए डम
अरे जहाँ से उखड़ेगा फिर वो टेंट हो जाएगा
आई थिंक यू शुड स्टिक टू
मुझे
क्लैट ब्रो
पता है, मुझे पता है।
आई थिंक यू शुड लीव क्लैट एज वेल ब्रो
छोड़ ही दिया अब तो क्या है।
भाई
तो फोटो ले वहां से नितेश
इसकी स्टोरेज इतनी फुल है
वही।
तो
शॉर्ट सक्षम ना कर देते
सक्शन को यार
फोटो खिंचवा से
नहीं गिरेगा
निकाले ना मेरे को देखना है
देयर इज जीरो चांस पूरी क्लास गिर रहा है
एक्चुअली वहां पे
वही तो बोल रही हूँ नहीं होगा
दिखा 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 दिखा
पीछे का
वो डाले वापस
हाँ वो इतनी धनुषी रहने ना
अरे डाले
रहने ओके
अरे सर पूछेंगे क्या कर रहे हो
हाँ
सर वो
मेरे
इन
पे
सब
नाम
चीज
है।
सो साइंस एक्सपेरिमेंट
तो सक्षम
मैं-
पोस्ट
मैं-
कर देती
सो
हूँ।
टेस्टिंग द पावर
मैं
ऑफ
चाहूंगा तू भी इसको ज्यादा जोर से नहीं
भाई मैं हर जगह कल गई थी हर जगह चिपक रहा था इसलिए मैं अब उल्टा ही रखती हूँ फोन वरना उखड़ता ही नहीं है
रहने
It's just a random phone hanging.
टाइम लैप्स ऑन कर दे
हाँ यहाँ हम पढ़ रहे हैं उसका.
स्टोरेज ही नहीं है कहाँ से
Fuck off. वो economic test results देखते हैं.
वही देख रहा था
Dash 25, Prish 22, Ansh 19, Sayam 15, Yashvi 20, Devansh absent, Areen 21, oh Areen. Call 25, Manan
those who have
30.
bought the uniform please pay money for this
Listen, out of
कौन
30,
सा uniform?
Manan
What?
Manan 30.
Nice. Out of 60,
Out of 60, Manan 32. Why Manan?
one close enough.
Who पे out of 60 को 50 कितने जाएगा?
ब्रो
दिशा
क्या
पर
चाहिए
रिकॉर्ड कर रहे हो
ईगो है
हाँ सर मैं क्या कही मैं गाड़ा क्यों बोल रही
तो
हूँ?
मान लो चलो Questions? questions
हाँ question answer सर પછી કાલે કેવો ટ્રાન્ઝિશન ને ક્વેશ્ચન મોકલેલા એ કોઈ સમજાય
અરે આગળ પાછળ તો કર્યું છે મોદીજી
હા.
કરી
હા.
પાકું કરી દઈશું क्लास પછી એ કરીએ
Sir, 2020.
સર 4 3 તમે ફોર્મ
અચ્છા.
બોલશો સર
x. Okay, the question is from 430 and 19. Right? The question says, what does the question say? Bromic acid HOBr is a weak acid with Ka. Calculate the pH of 0.2 mole per dm cube of HOBr. कैसे करेंगे? So they have said HOBr is a weak acid which has a Ka of 2 into 10 to the power minus 9. है ना? I am not writing units as of now, right? But can I write that HOBr will dissociate something like this, H plus and OBr minus, है ना? So if this is 0.20 mole per dm cube, right? So can I use Ka is equal to x square upon 0.20, and the value of Ka is 2 into 10 to the power minus 9. So 2 into 10 to the power minus 9 multiplied by 0.20 square root is the concentration of H plus. Correct? And if you just find out the minus of log to the base 10 of this thing, you actually have the pH. है ना? So pH, is this correct pH?
yes sir
Okay. So the correct pH is 4.7.
સર મારો એને નીચે ઓર્ડર
हाँ મને ખબર છે પણ pH યુઝ થશે ને
હા થશે બટ લાઈક મારી ખબર નહીં આ તો થઈ ગયું
મારા દેખી દે
સર આ પછી ક્વેશ્ચન છે એમાં હું તમને સમજાવશે એમાં હું
right makes sense
4.698.
ठीक है तो 4.7 लिखिए now they are saying 5 centimeter cube of this 0.20 mole per dm cube of potassium hydroxide solution, right? This is KOH and this is added to 20 centimeter cube of this 0.20 mole per dm cube of HOBr, right? Calculate the pH of buffer solution that is produced. है? So what can I write? I can write KOH dissociates to K plus and OH minus. In this case, what is the value of OH minus? The concentration of OH minus is again 0.20 mole per dm cube multiplied by 5 upon 1000 will give you the moles of OH minus. What do you find over here? क्या मिलेगा भाई? Can you? अरे एक सेकंड कैलकुलेट द pH. You can directly use this equation. pH is equal to pKa plus log of concentration of acid upon salt. In this, so you don't need anything else.
આ ફોર્મ્યુલા
Acid upon salt.
bookmark salt.
I think salt
क्या है? શું વાત કરે છે?
हाँ acid upon salt જ છે. Salt अरे ना अरे 450.
450 is it?
Yes.
बेटा एसिड अपॉन सॉल्ट છે. अच्छा
pH માટે
log માં ઓકે log માં ચેન્જ થઈ ગયું છે. Right. Salt upon acid would catch it. Salt upon acid. Right? Directly find this. है ना? Here also salt upon acid and here also we must change this to salt upon acid. है ना? Directly find this out. Ka is given. You find out this and this concentration is given. है ना? I believe सब कुछ मिल जाएगा. Right? Next.
Except for the first one.
Okay, the question comes from 4 to ON 23. 4 to ON 23 भी कर लिया अपन. Calculate H plus concentration of C6H5CH in the buffer solution described. Use the expression for Ka. when the question starts over here, they have given one, the weak acid Ka of benzoic acid is given. इसका Ka is 6.31 into 10 to the power minus 5 mole per dm cube. Right? Ka of this thing is given in the question. Now they are saying and slightly greater mass of sodium benzoate. Okay, so they have used 1 gram of this and slightly greater mass of sodium benzoate, which is C6H5COO Na. The pH of this solution is 4.15. Okay, now they are saying that use the expression to calculate concentration of C6H5COO Na plus in the buffer solution. So you are working and give each answer to a minimum of 3 significant figures. If you have 4.51 as your pH, then 10 to the power minus 4.15, sorry not 51, will give you the concentration of H plus. Right? From here you can work it out like this, that C6H5COOH dissociates to C6H5COO minus and H plus. The concentration is 10 to the power minus 4.5.
उसकी concentration.
Right? This should also be 10 to the power minus 4.5. And actually this should also be 10 to the power minus 4.5. Right? You find out the concentration of this thing. Then they are saying find out the concentration of C6H5COO Na in the buffer solution. So what you should do is see C6H5COOH concentration upon like this thing.
C6H5CO minus and H plus.
And H
तो
plus.
उससे अपने को pH मिल
This
जाएगा.
will give you Ka.
pH है? हाँ sorry K sorry.
Ka is already known.
Yes.
You know the value of H plus.
Yes.
Can you find out the value of C6H5COO
Yes. तो
minus?
इसमें अपने assume नहीं करेंगे कि वो दोनों same है. मतलब
हाँ अच्छा वो भी मिल गया. तो can you also find out the concentration of this thing? How much of this was dissociated?
अपने ने वो भी ढूंढा था ऊपर.
नहीं, अरे this is 1 gram of this is added.
हाँ.
है ना? To 1 dm cube of 1 gram of added and a slightly so 1 dm cube of water में 1 gram of C6H5COOH add किया. So what will happen? I can find out the concentration of C6H5COOH.
बट अपने ने वो ऊपर वो साइकोमेट्रिक रेशियो से नहीं निकाल दिया.
वो दो निकालने पड़ेंगे ना, तब मालूम पड़ेगा कि C6H5COO माइनस इसमें से कितना आया और एक और रिएक्शन से आ रहा है ना भाई C6H5COO माइनस प्लस Na प्लस, ये भी तो है.
हाँ.
पर हमने जो यहाँ पे ढूंढा वो तो इक्विलिब्रियम कॉमन आयन ढूंढा है. अब हम क्या करेंगे, अब हमारे पास ये अभी इक्विलिब्रियम में शायद इतना होना चाहिए. है ना? This is logic that these two are equal, but ऐसा तो होगा नहीं. So 1 gram से what you will do, you will discard this. 1 gram के हिसाब से इसका concentration क्या होता है ना? And using Ka find out the concentration of this thing. So this is एक जगह पे ये मिला, दूसरे जगह से ये मिलेगा कि इसका concentration कितना होता है.
तो अपने 6.31 into 10 power minus 5 multiplied by 10 raised to minus 4.
क्यों? नहीं
K क्यों मल्टीप्लाई कर रहा है?
Ka is equal to H plus into A minus इधर देख भाई.
हाँ.
You don't know the concentration of Ha.
Okay.
So Ha is equal to H plus
डिवीजन में आएगा.
A minus upon Ka. So you find out concentration of Ha here. You find out the OG concentration from the value in the question.
1.58 into 10 power minus 5 आया है.
कितना आया?
1.58 into 10 power minus 5. मैंने 10 raised to minus 4.5 का स्क्वायर किया.
हाँ.
अपॉन 6.31 into 10 power minus 5.
Sorry, मार्क्स की भी ओपन कर दो. तो हमको 1.58, right? Can you also find out कि C6H5COOH अगर 1 ग्राम लिया है तो what is the concentration over here? assuming all of this 1
So
gram
this is for 1 mole. तो अब 1 ग्राम के लिए 1 अपॉन
नहीं ये अलग है।
अच्छा ये अलग है।
ये क्या है मेरे भाई सुन, ये हमने Ka की वैल्यू से मालूम किया कि इस इक्विलिब्रियम में C6H5COOH राइट, यहाँ पे A माइनस एंड H प्लस प्रोड्यूस हो रहा है।
हाँ।
अब ये H प्लस हमको pH से मिला।
हाँ।
लॉजिकली इन दोनों का कॉन्सेंट्रेशन इक्वल होना चाहिए, बट ये इक्विलिब्रियम है।
हाँ।
तो इक्विलिब्रियम में ये उतना ही होगा ये जरूरी नहीं है ना।
हाँ।
ये इतना यूज हुआ है ये जरूरी है।
हाँ।
तो ओरिजिनल पहले फाइंड कर
दिया।
ये वाला वैल्यू ये रहा।
हाँ।
ओजी वाला वैल्यू तेरे को 1 ग्राम वाली वैल्यू से मिलेगा।
ओके वो कैसे मिलेगा अपने को?
ये बात इसका तू एमआर फाइंड कर 12 into 6 plus 1 into 6 plus कितना है 16 into
122
ये 122 हो जाएगा। तो 1/122 मोल ओरिजिनली था, है ना। इक्विलिब्रियम में कितने मोल है? इक्विलिब्रियम में 1.58 into 10 to the power -5 मोल है। तो बाकी का क्या हुआ? डिसोशिएट हुआ।
सर 12 into 7 है हमारा।
हाँ अरे वो लेकिन
हाँ।
मैं तो 122 वही करके निकाला।
अच्छा ठीक
12 into
7 होगा सर।
ओ राइट C
84 plus 6 plus 32। हाँ।
कोई बात 122 तूने करेक्ट निकाल दिया। अब 122 अपॉन 1 आएगा।
हाँ क्योंकि 1
DM क्यूब है।
हाँ
1 DM क्यूब भी है। ये 1 ग्राम का मोल है मेरे भाई।
अच्छा वो कंसंट्रेशन
और ये 1 DM क्यूब है। हाँ। Now what do I find? I find that the actual concentration is 1 upon 120।
हाँ।
होना कितना चाहिए था भाई? 1 upon 122 है कितना? 1.58 into 10 to the power -5। तो बाकी का गया कहाँ? बाकी का डिसोशिएट हो गया।
हाँ
है ना।
माइनस करेंगे
क्या आएगा?
0.58 into 10 का -5 8.18 into 10 का -3।
अब मेरे एक बात बता कि 10 to the power -4.15 कितना होता है?
7.0 10 का माइनस
7.0 10 पावर
सर 4.5 ना
4.15 देख ले भाई।
व्हाट
pH 4.15 है ना क्वेश्चन में 4.15
सर ना
आंसर करेक्ट 4.15 करेक्ट है
भाई
4.5 यूज किया कब से?
अरे मेरे भाई तूने जो यूज किया क्वेश्चन में 1.5 है।
क्वेश्चन में दिया होगा ना 4.1
तो फिर आंसर कैसे सही आया 4.5 यूज करके?
वो सरप्राइज
देख इसका आंसर क्या आया मेरे को ये बता।
10 raised to power
-4.15
7.0 से हाँ 7.0
into 10 to the power -5
करेक्ट है
राइट
एक्सप्रेस में करेक्शन
है ना। अब देखो सो कैन आई से दैट इसका भी कंसंट्रेशन 7.08 into 10 to the power -5 है।
हाँ एनायन का
है ना।
हाँ
ये ब्रो तेरे को एक बात बता कि यूज कितना हुआ है? यूज तो इतना हुआ है,
हाँ
है ना।
हाँ
अब ये इतना क्यों है? क्योंकि थोड़ा
डिसोसिएट हुआ
दूसरी इक्वेशन से मिला है।
हाँ दूसरी इक्वेशन भी यूज हो गया ना
तो उसको सब्ट्रैक्ट कर और जो आंसर आएगा दैट शुड बी योर कंसंट्रेशन ऑफ द सॉल्ट।
C6H no
हां C6
NaNO ओके
सर तो
एन का
अबे वाला
हाँ मतलब बे वो तो मेरी
और यूज कर अच्छा
नो बेटा दिस इज द value available in the concentration right now it should have been this much after getting 8.2 भी करें एक पद से हाँ। So I find that the available value of this acid is this much should have been this much
ओके
So,
हां
है ना। तो where did the rest of it go? The rest of it has made this solution right but this A minus does not come from only the acid it also comes from C6H5COONA. So how much ever came from acid if you subtract that from the total quantity you will find out how much came from salt
हां
that will be the concentration of salt.
अच्छा दैट इज आंसर तो हमारा 7.31 and 8.1 का तो 7.9 होगा
ये लोग को एज करेक्शन see H plus concentration we found out that 7.08 into 10 to the power minus 5 right then how will you find C6H5COOH by using Ka
हाँ और उसमें मतलब
है ना जितना H plus का concentration होगा उतना ही C6H5COO minus का concentration होगा
इसका आंसर आता है 7.94 into 10 power minus 5
अब इसका आंसर क्या आ रहा है Ka से आंसर क्या आ रहा है
हाँ अपने 7.94 into 10 power minus 5
so C6H5COOH should have been 7.94
into 10 power minus 5 अपने 10 raised to minus 4.15 का स्क्वायर करेंगे अपॉन 6.31 into 10 power minus 5 करेंगे हाँ उससे ही आता है
अब मेरे को ये बता कि इसका 1/22 का आंसर क्या आ रहा है
1/22
because this is 22
1/2
that means
8.2 into 10 power minus 3
8.2 into 10 to the power
minus 3
minus
और
3
subtract कर सुना
है ना तो see in equilibrium it should have been this much
हाँ
है ना but originally you had added so much
हाँ
so subtraction
right
हाँ
so if you subtract what will you find
ठीक
भाई
है
एक सेकंड इससे ही आंसर आ जाएगा this is the answer
but sir this is
अच्छा to find out the C6H5COO minus this can be used है ना कि ये वाले वैल्यू से इसको यूज कर सकते हैं
नहीं समझ रहा
ढूंढना क्या है
हुंडा
एक
नहीं
काम
ढूंढना है ना
हाँ but third value the concentration of C6H5COO and you have to find the concentration of this in this you have to consider a common ion effect that C6H5COOH dissociates to form C6H5COO minus and H plus and C6H5COO minus and Na plus was produced from C6H5COO minus Na plus right you already know the concentration of this combined है ना कितना है
7.94 into 10 power minus 5 नहीं
हाँ वही
वही
7.94 into 10 to the power minus 5 इसका concentration कितना है इसका concentration मिला 8 point from here into 10 to the power minus 3 इसका भी मिल गया
7.0
minus 5
फिर वो बफर सॉल्यूशन में pH में इक्वेशन से कर रहा है
क्या
pH है pK થઈ જશે
Okay.
અને
Acid का पता है।
एसिड ना
वाह वाह वाह
concentration
केमिस्ट्री pH is equal to pKa the log of salt upon acid if you know acid if you know pKa you know
Yes.
pH you can find out the concentration
4.15 minus
or rather you can actually directly use the H plus is equal to Ka multiplied by concentration of acid upon concentration of salt. This will be easier.
हाँ this is the more simplified version
so 0.9999 आ रहा है इसका
क्या बात कर रहे हैं ठीक है
मैंने 4.15 minus 6.31 into 10 power minus 5 किया
4.15 minus
pH तो 4.15 है ना
pK तो अलग है ना वो K
pK तो
pK तो negative log of K
उसे
है ना भाई
ना फिर वो उसे निकालना पड़ेगा
negative
Ka
log of
Ka is 6.31 into
10 power minus 5
6.31 into 10 to the power minus 5
yeah so
right
pK का ऊपर से पहला है
okay
minus log
what is H plus concentration
Oh,
H plus
7.0
concentration
10 power minus 5
7 point so 7.08 into 10
10
to
power
the
minus
power
5
minus 5 divided by
K of salt is something that you have to find
divided by Ka
no sir
हैं
divided by salt that you have to find
नहीं वो एसिड नहीं है ना H plus एसिड तो ये रहता है C6H5COO
by एक सेकंड ना
log
सर आप और
शॉर्टकट
ये
करने की जरूरत नहीं है
ऐसा आपका ये जो
अरे
आप
bro H plus concentration multiplied by or rather salt concentration is equal to Ka into acid
सर 2.63
Upon H
minus
plus the
32.
constant. हाँ.
क्या ये किया
ना मैंने
6.31
इसे आप ये क्यों हटा दिए?
क्योंकि भाई वो इजी है
आपने लॉग हटा दिया इस जगह से।
हाँ एसिड कंसंट्रेशन कितना मिला है 8.20 into 10 to the power -3 मिला है ओके एंड व्हाटएवर इट इज
H plus का concentration तो 7.08 into 10 power minus 5
एसिड अलग है एस प्लस अलग
हाँ,
है
हाँ, वो H plus
7.31
Acid
into
तो
7.31 into 10 to the power -13 is it 3
-3
K की value 6.31 into 10 power minus 5
this equation will give you the
divided by 8.2 minus 3
good
upon
Sir,
ठीक है अब नेक्स्ट जाते हैं
एक है ना सर
टाइप ऑफ सम्स થઈ ગયા હવે નેક્स्ट ચેપ્ટર માં જઈએ
बट सर एक बीजो टाइप थियोरेटिकल
करिए लेवल 2 1 નો विजय से करिए
K की concentration 6.31 into 10 power minus 5
हाँ
लाइक रिएक्शन काइनेटिक्स एकदम सिंपल स्ट्रेट फॉरवर्ड इजी है
-4.15
यस
डन है cool okay so reaction kinetics how fast is a reaction taking place है ना the rate of reaction we know can be changed by temperature catalyst concentration
लार्जर स्मॉलर पीसेस
surface area है ना now the concentration sorry how will you find out that what is the rate of reaction in the last year we have just understood what influences the rate of reaction this year we are going to see what is actually the rate of reaction so how do you measure rate of reaction कैसे measure करेंगे
rate
volume
equation
of gas volume divided
volume
by
of
gas.
gas produced concentration of product produced concentration of reactants decreasing है ना now if you plot this concentration of reactants changing over time you will get different curves है ना if it takes let's say 100 seconds to go from 1 mole per dmq for the reactants to 0.25 mole 0.5 mole per dmq and it takes again 100 seconds so equal time to go from 0.5 to 0.25 what is actually happening as the concentration of reactant is decreasing the rate of reaction is also decreasing
या
है ना what would not like how would you judge that the concentration of reactant does not affect the rate of reaction that even if the concentration of reactant decreases the rate of reaction still remains same okay in that case it does not affect right so according to how much does a concentration of a product right sorry a reactant right now we are only learning about reactant sometimes products can act as catalysts
या
right but here we are only learning about how reactants change the rate of reaction okay so what I was talking about that from 1 dmq to 0.5 mole per dmq and from here to 0.25 mole per dmq
यस
if this also takes 100 seconds and this also takes 100 seconds then the change is equal
कांस्टेंट हाफ लाइफ
right this is nothing but a constant
हाफ लाइफ
half life
फर्स्ट ऑर्डर
if it has a constant half life it means it is directly dependent
यस
right it is directly dependent so the influence right before we understand what is order so let's say this is reactant A plus B giving C and this graph is plotted about concentration of A and the rate of
Reaction.
reaction
रेट ऑफ रिएक्शन अगेंस्ट कंसंट्रेशन
right we just relating these two
Yeah.
what is the change in rate of reaction when the concentration changes right or the change of rate or the decrease of concentration over time क्योंकि हमने 100 seconds लिखा है if this is equal if the half life the time taken to half itself of the initial concentration then this is known as first order the influence is equal to 1
1
it decreases and decreases the rate of reaction equally
equal
वो जितना डिक्रीज होता है उतना ही रेट ऑफ रिएक्शन भी डिक्रीज होता है. वो हाफ हो गया, रेट ऑफ रिएक्शन हाफ हो गया. वो 1/4 हो जाएगा, रेट ऑफ रिएक्शन 1/4 हो जाएगा. सो A raised to power
1
rate of reaction is directly proportional to A raised to power
-1 but positive one.
right. Let's say that this is, when I calculate according to this, then going from 1 to 0.5 takes 100 seconds, right? Going from 0.5 to 0.25 takes 200 seconds, or let's say 50 seconds. Then what has happened?
Your half-life has reduced, like around half.
Okay.
Half-life, half.
Or instead of even learning this, right, look at it like this, that this is concentration and this is time, right?
Yeah.
As the concentration decreases, right, there is no curvature to this, it keeps on decreasing, right? Does not matter if the concentration was 1 mole per dm cube or 100 mole per dm cube, the rate of reaction remains unchanged, right? The rate of reaction remains unchanged. Then the influence of that is 0.
Sir, concentration against time graph 0 order ना first order નો graph હશે. time છે ને તો તમે એક તમારો concentration
rate of reaction.
હા એ સર એ rate of reaction against concentration ના graph માં આપણે આ ફર્ક આવે. સર એમાં કર્વ આવે, એમાં કર્વ આવશે.
ભણી ના આવે યાર.
હા
હું ભણી યાર. Okay, what should the curve look like? This is concentration and this is, let's say, time.
okay.
Okay?
Yeah.
What should happen? What are you saying?
Sir, if 0 orders, then a flat line because no effect ideally. That's what it is.
Right?
Concentration
Yes, sir.
अरे टाइम સાથે આવું નહોતું દોસ્ત. This is,
Sir,
look at
reaction
figure
rate is
4.69. This is with rate of reaction.
Or was it the opposite?
So if you, I was right there. I was cooking right.
I have to
Okay.
uncook what I put.
This is rate and
नीचे
this is
concentration.
time. अरे
सर
हाँ,
आपने
it's like-
ये ग्राफ में सर जीरो ऑर्डर में फ्लैट लाइन होती है सर रेट ऑफ
बाय रेट ऑफ रिएक्शन और concentration है. मैं वो नहीं ड्रॉ कर रहा हूँ. मैं
आप
22.4 ड्रॉ कर रहा हूँ.
आगे
time.
नाइस
कोई तेरी है कोई बात नहीं. 22.4 की मेरी
मेरी
पागल है.
Fine.
Right? This is what the graph looks like. मैं correct cook कर रहा हूँ.
Yeah.
I appreciate all your feedback, but let me. Okay. So A raised to power 1, B raised to power 0. Because the concentration or the amount of B does not influence the reaction at all. And the total rate of this reaction becomes 1 plus 0, which is 1. The all over rate of reaction becomes 1. ठीक है?
Yeah.
Now I have written proportional. So how do you find out the rate of reaction? Now what you have to do, right? So rate is equal to K into A raised to the constant raised to power 1, and you don't need to write B because anything raised to power 0 becomes 1. Right? Now if you want to find the value of K, you have to write rate upon the concentration of A. Now what will you do? You will take the initial rate of reaction and initial concentration. You can easily find the value of K. Right? This K is a constant. For every rate it may be a different number. Until unless you know all the influencing parts of the reaction. You know which reactant has what order to the rate of reaction. You cannot find out the value of K.
Okay.
Yeah.
Yeah.
The units of K will keep on changing with every rate equation. This thing is known as rate equation. The value of K keeps on changing, but also the units of K keep on changing. Why? Let's say that the rate of reaction is, the unit of rate is mole per dm cube per second. The change in concentration per unit time. है ना?
Yeah.
What is this? This is mole per dm3. Correct? So here the value of K, the value or the unit of K is
1 by
going
S.
to be 1 by S. Now imagine if there was a rate of reaction which depends like this, K into A raised to 1 and B raised to 1. What will happen? The unit of rate is still mole per dm3. The unit of concentration, the mole per dm3 per second, the unit of concentration is still mole per dm3. But what you will find, the unit of K will change because this is mole upon dm minus 3 into S minus 1 upon mole raised to 2 dm raised to minus 6. Okay?
dm3 by mole S.
That will keep on changing, right? So every time you will have to find out the value of rate constant and the unit of rate constant. Even if you cannot figure out the value of rate constant, it can be easily found out. You can easily find out the units. These units are important. एक मार्क का unit बोल देते कि जाओ unit find करो, है ना? 2 मार्क में से 1 मार्क सिर्फ unit. So you should be able to find out unit every time. Make sense?
Yes.
है ना? All over order से भी तुम लोगों को hint मिल सकता है कि what will be the unit of K. When the order is 1, the unit is 1 per 1 by second.
Yeah.
है ना? When the unit is 2, when the all over order is 2, तो यहाँ पे क्या हो जाएगा? यहाँ पे हो जाएगा dm cube upon mole into 1 by second. जब 3 हो जाएगा तो you can calculate and find out this will be dm6 mole square 1 by second. So if you know the all over rate even without calculation, you can still find out the units of rate constant. Make sense? Yes. Now there are a few graphs given which I believe you should all look at. है ना? कि 22.3, 4, 6, 9 page पे दिया है. They have said that the rate of reaction and the concentration of reactants. If the rate of reaction does not influence, the concentration of reactants which is on x-axis does not influence the rate of reaction, then it is a first order, zeroth order. If it influences equally, खुद increase हुआ rate of reaction उतना ही increase हुआ, खुद double हुआ rate of reaction भी double हुआ. If it influences only how much it itself increases, then it is first order. But it increases twice, it influences twice, right? It is second order. It can influence thrice, which can be third order, so on and so forth, right?
ज़्यादा steep होगा.
The graph will get steeper and steeper. What is important thing about half-life? In zero order, the half-life decreases. जो मैंने पहले draw किया था 100 second and 50 second. वो कम intuitive हो गया था because पहले हमको ये नहीं मालूम था कि कैसे influence होता है. But if you look at the figure 22.6 on page number 471, just the next page, right? Next to next page, I mean.
Yeah.
तो उसमें क्या लिखेगा? उसमें लिखेगा that the value of second half-life for the zero order is less than the value of first half-life. In first order, the half-lives are equal. In second order, the second half-life will be longer. क्यों हुआ ऐसा? Because when the concentration decreased, the rate of reaction decreased by twice of that.
Correct.
है ना?
Yeah.
So the half-life would increase.
Yeah.
First, it required 100 seconds to get half of it. But now it is half. So the rate of reaction is 1/4. So it will take double time to get half. And this will keep on happening over and over and over.
That will be second order, right?
Right? Now the rate, this rate constant or the influence, है ना? It can only be found out, right? The order of a reactant can only be found out practically. It can only be found out practically. You cannot find it theoretically. So they will give you some practical table that okay, so much is the concentration, so much is the rate of reaction. Find out the order of each reactant, right? If you want to have a look, you can find out such things. Just a second. If you look at page 476 on table 22.4, right? You will see that they have listed concentration of hydrogen peroxide and concentration of I minus and concentration of H plus, right? 472. Now if you look at topic 22.5, 22.5 में they have given the equation, then they have given this table, है ना? Now if you look at this table, you will find that the first and second reaction can be compared. Better left side पर 472 22.4 deliver, right? You look at this equation, you will find out कि first और second में what is the comparison? The comparison is the concentration of H plus is kept constant, the concentration of I minus is kept constant, only the concentration of H2O2 is made 1.5 times. What you will do? See, you will find 0.0300 upon 0.0200 and you will find the value of 5.30 into 10 to the power minus 6, and this is 3.50 into 10 to the power minus 6, I believe, correct? Find out the ratio of these two things, right? Let's say इसका ratio आता है 1.5, which I think is obvious, है ना? I believe इसका भी ratio 1.5 होना चाहिए, approx, so 1.49, 1.5138, something like that. Approximation is okay, right? So if you increase the concentration by 1.5 times, the rate of reaction also increases 1.5 times. So the H2O2 is first order. Now let's look at a little bit more data. Now what they have done, they have decreased in the third reaction, they have made I minus and H plus concentration the twice of initial concentration. But what they have done, they have decreased the H2O2 concentration by 4 times, right? So what you will do, now you will see always
So 4 times, 6 times, na?
okay, this is what I was going to say, always compare it with the first reaction, do not compare internally, okay? First reaction is your baseline, so you have 0.0050 upon 0.0200, right? What is answer here? 1/4.
Yes.
Now for, let's take this is 1.75 into 10 to the power minus 6 upon 3.5, is it?
Yes.
Into 10 to the power minus 6.
1/2 होगा ये.
So ये 1/2 हो रहा है. Now what is happening? I minus and H plus, both of their concentrations are doubled. है ना? What is the cumulative effect of both of that doubling?
Reaction आधा हो रहा है.
So basically 1/4. See, only if this could influence, only if H2O2 could influence, this rate of reaction should have been 1/4. But it is actually 1/2 only. So it is twice of what you have expected. So either of this, right? They have doubled both of them. One has an order of 0. One has an order of 1.
फर्स्ट ऑर्डर 3 होगा ये रिएक्शन.
फर्स्ट ऑर्डर ही होगा ना.
क्यों? अगर जीरो ऑर्डर में कुछ
पहले तो देखा कि H plus का concentration और I minus का concentration
Double
दोनों को डबल किया, है ना? अगर दोनों का फर्स्ट ऑर्डर होता तो टोटल ऑर्डर कितना हो जाता दोनों का मिला के? 4 टाइम्स. तो तेरा रेट ऑफ रिएक्शन 4 टाइम्स हो जाता. तो एक्चुअली रेट ऑफ रिएक्शन चेंज होता ही नहीं यहाँ पर. मेक सेंस? बट रेट ऑफ रिएक्शन जितना एक्सपेक्ट कर रहे हैं जस्ट बिकॉज ऑफ H2O2 इट इज डबल्ड, है ना? सो व्हाट यू विल फाइंड दैट द
अच्छा वॉल्यूम डबल हुआ इसलिए सेम ही रहेगा.
either I minus or H plus, either of them is influencing the
तो अगर
reaction.
वॉल्यूम सेम रहता तो फिर अपने फर्स्ट और सेकंड ऑर्डर जाता है. तो फिर सेकंड
order. But also if you look at the equation, they say that the rate equation is KH2O2 just above this, है ना? Table topic 22.5 में they have said that the rate of reaction is K into H2O2 I minus. They have already said that K is equal, sorry, not K, rate is equal to K into H2O2 and I minus. इसका मतलब क्या हुआ? इसका मतलब हुआ कि H plus is already zero order, है ना? So you don't need to consider H plus. I minus में क्या हुआ है? I minus में double हुआ है concentration. And what has that? See, now what you can do? I minus का double मिला, इसका 1/4 मिला, पर इसका 1/2 हो रहा है. मतलब जब I minus has doubled, the rate of reaction is also double the expected rate of reaction. So that is also first order. Now it should be very clear to you. I have already written raised to power 1 in both of these concentration. It already means that it is first order with respect to these two reactions. Makes sense? है ना? So one more thing about rate of reaction is it tells you that what all, sorry, again writing it incorrect. Rate is equal to K into A and B. Right? There are two things that we can learn from the rate equation. First, what all influences the rate of reaction. Second, what should be the rate determining step. Now sometimes what happens is a reaction may not be just one reaction. है ना? One step नहीं होता है. For example, let's look at how iron.
चलो चलो वापस आ जाओ बस. Okay?
Yes, sir.
So the A and B also appear in your rate determining step basically.
मतलब वो स्लो स्टेप होता है.
Rate determining step. Why is the rate determining step slowest
क्योंकि
step? Or rather, why is slowest step the rate determining?
And because it contains of all the reactants that are in the rate equation, all of them that
No, it's
affect
inverse. The
हाँ,
rate
हाँ,
determining step tells you what will be in the rate
rate
equation.
equation.
है
सर
ना?
ऐसे याद रखते चलेगा लाइक सपोज एक रेस हो रही हो,
हाँ.
लास्ट जो भी होता है that will be the minimum time required.
Maximum
maximum
time.
time, maximum time वो
हाँ.
होगा.
Sorry, that will be the minimum time required to complete the race.
हाँ.
You are right about this.
हाँ
हाँ.
तो वैसे सोचा है.
सही बात है.
और अपने लास्ट स्टेप और दर वक्त से कोई पण
ना.
Last
It can
is
be any
slowest
step.
But
It has to be
no.
the slowest step.
सबसे ज्यादा टाइम जो स्टेप
Let's look at a why ढूंढ रहा हूँ. Let's look at an example, right? बहुत सारा ऐसे heterogeneous catalysis कैसे होता है, हाइड्रोजन हीरो प्रोसेस में कैसे करता है, डिफ्यूजन, एड्सॉर्प्शन, डीएड्सॉर्प्शन, सब कुछ लिखा हुआ है. This can be a 3-mark question, है ना? But basically लिखना तो यही है ना? ट्रांजिशन एलिमेंट से कैटालिटिक कन्वर्टर का इक्वेशन फिर से दिया है, पर तुम लोग ये 10th और 11th दोनों में पढ़े हो तो वो आना चाहिए, है ना? Yes, Kenisha, come to page 479 with obviously everyone else. You will find that figure 22.12 और 22.13 दोनों तो बाजू-बाजू के पेज पे है ना? एक रिएक्शन में कुछ तो मीथ ईथ प्रोपेनोन है ना? Propanone is changing a lot of states, but the second reaction is the slowest reaction.
Yeah.
So the reactants in the second reaction become the
वो फाइनल जो इक्वेशन
है ना? That you will find in rate determining step, right? Also, if you look at figure 22.13, you will find out again the slowest step becomes the rate determining step.
ना लख्यो है तो क्या स्लो या फास्ट.
See, either they have to, because this can only be found out experimentally, either they have to tell you that this is the slowest step, right? Or they have to give you a rate equation, so you know what are the reactants in the slowest step. Right? Sometimes they will ask you, they will give you rate of reaction, they will give you the all over reaction, they will tell you find out the rate determining step.
આજે પાછળ છે એમાં આપણે a + b = d કર્યું.
हाँ.
એમાં
Because D is the final product.
બટ ઇક્વેશનમાં તો a અને c જ છે.
So basically A plus 2C gives B, and that B then combines with A to form D.
ઓકે સો
This is a slower step, so becomes the rate determining step. But I know this already that over here in the rate equation only A and C are the reactants that influence the rate of reaction. है ना? I want you to find out. See, from my side, reaction kinetics is explained, but I want you to find out at least one question from your past
The
paper.
paper from language question.
Right? Where we have to find out either the rate determining step,
So
or the rate of
question
reaction, or either the rate equation. Okay, so we start with again 4 to ON 2 3. Mr. Shaurya.
Yes, sir.
Okay, now propanone CH3, it is exactly the same example we have seen in our textbook. CH3CO, question number. CH3CO CH3 plus I2 gives, what is it? CH3. I think the equation is not that useful. CO CH2I plus H plus and plus I minus. In this situation, they have said that the rate equation is equal to K into concentration of CH3 CO CH3 raised to power 1 and I believe H plus raised to power 1. है ना? Next question they have asked. Order of the reaction with respect to CH3 CO CH3, your answer should have been 1. Order of the reaction with respect to I2 0.
Why?
Because it does not exist in
The
the
rate
rate equation. Then order of the reaction with respect to H plus
1.
and the all over rate of reaction
1.
With what addition of everything?
ठीक है? ये भी पूछ लिया हम लोग.
Yes.
Now they are saying an experiment is performed using a large excess of CH3COCH3 and a large excess of H plus. The initial concentration of I2 is so much. The initial rate of decrease of I2 is given. Use the axis to draw the concentration of I2. So they have said that initially I2 कितना है भाई? Initially 1.00 into 10 to the power minus 5 है ना? And it is decreasing with a rate of 2.27 into 10 to the power minus 7 mole per dm cube per second.
फिर हम क्लास में वेट करते हैं.
हाँ. फिर पूछा है heat. हैं?
Features तो यहाँ है.
My man is wild. In a class of exponential. Okay, now they have asked कि 10 seconds के बाद क्या होगा? How do I know 10 seconds के बाद? Because question में axis on the x-axis there is only 10 seconds. 0 to 10 seconds. So I know that they are asking कि 10 seconds के बाद क्या होगा? They are saying that per second this much is used.
Yeah.
From the rate equation, we know that the order of I2 is
0.
है ना? So what should the graph look like? If I look at the completion of I minus, then the I2, I mean the graph should look like this. Correct? If the graph should look like this is when the concentration becomes 0. But they are asking only for a certain time where it is only 10 seconds. So first thing I know is that it should be a straight line.
Yeah, and the graph is only of 10 seconds.
10 seconds. So if per second this much is used, 2.27 into 10 to the power minus 6 mole per dm cube will be used up in 10 seconds.
No. No, like, अच्छा हाँ in 10 seconds.
In 10 seconds, this multiplied by this is the amount of
और 10 है minus 6
iodine
करके तो
used up.
अच्छा हाँ.
Right? But the initial concentration of iodine is 1 into 10 to the power minus 5.
Yeah.
What is the graph about? The graph is about the concentration of I2.
Against time.
Not how much is it used.
1 minus
Against how much it is
Minus.
left over. Minus 2.27 into 10 to the power minus 6. Or rather I would write 0.227 into 10 to the power minus 5. So I will find this is 0.773 into 10 to the power minus straight line. At 10 seconds it should be ending at 0.77.
Exact values over there per second.
આવશે ગ્રાફ એટલું વ્યવસ્થિત આપ્યો છે કે આવશે Then state whether is it possible to calculate the numerical value of rate constant for this reaction from your graph. Explain your answer. No, because I2 has an order
No
of
effect.
0.
Zero order.
Then the experiment is repeated at a different temperature.
Sir, like first no correction, પછી લખ્યું છે concentrations in the rate law and not known.
हाँ वही ना, लेकिन I2 का value नहीं
I2
equation में.
it is not influenced by I2. So only this graph cannot let you find the rate of reaction, right? Okay. The experiment is repeated at a different temperature. The initial concentrations of H plus and I2 and all of them are 0.2. The value of K at this temperature, calculate the initial rate. Rate is equal to K into concentration. They have already given you the rate equation. They have given you all the values now. And you have to find the rate of reaction. The experiment is repeated using an excess of H plus. Why are they using excess of H plus? So you can plot the rate of reaction and the concentration of propanone. H plus एकदम excess में, वो change ही नहीं हो रहा है comparatively. तो देखो किसका रेट का स्टडी मिल सकता है? दूसरे रिएक्टेंट का, क्योंकि वो डिक्रीज होगा तो रेट ऑफ रिएक्शन चेंज होगा.
Yeah.
Right? So you can find out the
K is equal to ln 2 by T half.
right. So what I will, they have said that rate is equal to K1 into CH3 CO CH3. Why? Because H plus is in a lot of excess.
Yeah.
So its concentration is not going to
Not
change,
change.
and therefore the rate of reaction will not change with respect to H plus concentration.
Yeah.
The value of K, they have said the value of K. Acha, I think I forgot to.
So half formula right half.
Yes.
Is equal to ln
I think you can find out K is equal to ln2 upon T
T
half.
half.
Right?
Physics
T half is nothing but the
Half right.
Yeah? Basically, K is equal to ln2 upon
T.
It is
K is already given.
So Joel, the decay constant isn't it the same as rate?
It is the
constant?
same. It is the same. All of these are exponential decays.
हाँ.
Right? That is why they can all have same.
log 2 ना use log 2
Nah.
अलग है से
0.6
अलग
में
अलग।
जाता है.
अलग
એટલે ઉપર log અને નીચે
Exponential
log.
है to the base 10 nothing. Exponential. Right? So you can find the value of T half from this equation. Now they are saying use your answer to draw a graph of this against time for the reaction. The initial value should be 0.2 mole per dm cube and the final value should be 0.0250. So you go from 0.200 to 0. कितना बोला? 0250. तो कितने हाफ लाइफ आएंगे? पहले एक बार हाफ होगा,
तो 1 I just
0.1, फिर हाफ होगा
0.05.
and then right 3 half life.
half है.
Right? हमको हाफ लाइफ मिल गई है.
हाँ.
आइडियली हाफ लाइफ कितनी होनी चाहिए दोस्तों? फाइंड करो ना कि t is equal to ln2 upon 1.1 into 10 to the power minus
630.
630 seconds होने चाहिए,
Yeah.
है ना? So what you will do, you will take your graph, you will find out 630 seconds over here,
Yeah.
है ना? पहले काम प्लॉट करेंगे, you will find 0.200 over here
Yeah, then 1.
at 0, then at 630 you will find concentration 0.100, है ना? Then at 1260 you will find 0.05,
1890 पे 0.025.
1890 पे 0.025. So you will find that it is a curve like this, which will give you the correct answer.
Correct.
And as it is, x-axis is open for you to plot. है ना? फिर देखो, this is a 10 mark question. इतना सारा पूछ के पूछा है सिर्फ 10. A 4-step mechanism is suggested for the overall reaction. They have again, for your convenience, they have written the whole reaction and they have still written the rate determining step. So you don't forget which should be the slowest step. है ना? Sorry, the rate equation.
Rate equation.
Now you look at step 1. In step 1, you will find that the reactants are CH3, CO, CH3 and H plus. In the second step, it is CH3, C plus, OH, CH3. Right? I am only talking about reactants. Okay? In the third step, they have asked you to fill in the blank. Okay? How will you fill the blank? Let me write the second equation first. So CH3COH double bond CH2 plus H plus. Now this has already been taken care of, right? And if you look at fourth step, right, it is CH3C plus OH CH2 I gives CH3COCH2I plus H plus. Now if you look at your all over reaction, H plus should be there in the product side, right? These H plus, let me do it with another pen. These two H plus cancel each other out. This is on reactant side, this is on product side. So only this should be your reactant.
Equation.
है ना?
Yeah. And then
Double bond CH2. Now this should react and form this CH3C plus OH and CH2I. Now if you look at your all over reaction, on right hand side there is an I minus.
Yeah.
So add an I minus over here. If I have an I and I minus, it should come from I2, which is a part of your reactant.
Yeah.
So you have constructed step 3 from the knowledge of step 2, the all over reaction, and step 4. Then what do you have? Write an equation for step 3 that we have already written. Then suggest the slowest step of the reaction. Step 1. Because है ना?
In the rate equation.
Very nice. The reactants in rate equation appear in the step 1. So step 1 has to be the rate determining step. Identify one conjugate acid, conjugate base pair in the mechanism. What is a conjugate acid and a conjugate base?
Charges दोनों opposite हैं.
ठीक है?
और एक acid और एक base.
एक साइड पे
No.
एक्सेप्ट करता है दूसरी साइड पे
Yes.
दो reactor.
जो एक साइड पे एसिड है दूसरे साइड पे जाके बेस बन जाएगा ना. So what can I write? See, look at the first step. In the first step, the product is CH3, C plus OH and CH3. Here, this has acted as a proton acceptor
Base.
है ना? So on this side, it is a base.
Yeah.
But this side it is a conjugate
Acid.
acid. So this can be your conjugate acid. Now if you look at what do we have? Yes, if you look at this, right? This has what has happened over here?
Yes.
What has happened over here?
It has lost a proton. मतलब proton दोनों.
Sure?
Yes.
100%?
Yes. तो acid है वो तो
क्योंकि H plus यहाँ पे निकला है.
Conjugate base, conjugate acid.
This is conjugate acid and this is conjugate base. That is your answer and that is the question that we solved. And I think this should suffice for this chapter.
Yes.
You have any more doubts? You can come in class at 11 a.m. Get all your doubts solved.
Rate determining